Hey guys, Oric here, going over the practice final. I just put the calculator up on the screen, so maybe that would show up as the header for my video. I'm going to go over the first 20 questions, and hopefully this doesn't take too long. There are some really tricky questions on here. My advice is to maybe watch, you know, 5 questions, something like that, and then take a little break, especially a few questions in the second half. It's pretty long, and you probably don't want to sit and watch or listen to this for the full 20 questions all at once. Make sure you ask me any questions, or let me know if I do end up making a mistake on this. All right, so this very first question, recursive rule. With recursive sequences, we to find any term in the sequence, we need to be able to find the term before it. So it's always in terms of the term before it or the two terms before it. So you have to be given the first term. So the first term we write as A1, and that equals -1. And as you can see from this, we're just adding 2 every time. So the next term, A2, and we'd write that AN. So any term we want to find is equal to the term before it, which is AN minus 1 plus 2. And this is our formula. And you could find, with this formula, and not given any of these numbers, you could find any number in the sequence. You could plug in -1 for a to the n minus 1 plus 2, and that would give us A2. Then we would end up with 1 for an answer for A2, and then we plug in 1 and add 2, and we get the third term, and so on. Now the explicit rule, and I have a formula sheet. I'll just take a look and see if I had it right here. I posted in a formula sheet on the Google Classroom of what you'll have for the test. This, you can tell, is not an arithmetic sequence. It's a geometric sequence. We're dividing by 3 or we're multiplying by 1/3 on every occasion. You can tell we're not adding the same amount or subtracting the same amount. So this is a geometric sequence. It's AN equals A1, which is the first term, times R, which is the common ratio, to the n minus 1 power. And if you ever can't figure out R, it's to take the second term divided by the first term. So 9 divided by 27 will give you R. And actually, any term, 3 divided by 9 or 1 divided by 3, should give you the same number. And if it gives you the same number, it will give you the same number if it's a geometric sequence. So A1 is the first term, so our formula or explicit rule is 27, R, which we found, which was 1/3, to the n minus 1 power. So if we wanted to find the 10th term, we'd do 27 times 1/3 to the 9th power, and AN. All right, the third question, a virus struck. So this is going to be another geometric sequence because we're going to end up multiplying by 3, multiplying by 3. So on the first day we have 1, and the next day we'd have 3, and then each of those 3 people give it to 3 people, so we'd have 9, 27, and so on. How many do we get on the 9th day? Well, once again, A9 AN is equal to A1, which is 1, times R, which we're multiplying by 3 every time. R is equal to 3, to the n minus 1 power. So if we want the 9th power, or 9th day, we'd put it to the 8th power, 9 minus 1. So 1 times anything is 1, so it's just 3 to the 8th power. And let's do that, 3 to the 8th. 65, 61. Yeah, I should have an answer key here, so I'll double check my work here. Number 4, we're not given the first term, so we'll call that A1, this A2. A3 is 17. 4, 5, 6 is 35. This is A1, A3, and A6. So what we're doing is we're going up 3 terms, and we're going up 18. We're going up 35 minus 17. So 35 minus 17 is 18. So we're going up 18, and we're going up 3 spots. We're going from 3 to 6. So I'm just keeping it positive here. So we're going to go up 1, 2, 3. So it's going to be 18 over 3 every time. So it's our D in this case, since it's geometric, or since it's arithmetic sequence, D equals 6. Geometric, you find R. Arithmetic, you find D. And if you can double check your work here, this would be 23 if we added 6. And if we had 6, we'd be at 29. And we had 6, we'd be at 35. So we subtract 6, we'd be at 11, and subtract 6, now we got our A1 is 5. And you could use that formula 1 on our sheet to find A1, but I think it's easier just to kind of think of it in these terms. And then what does it say? What value of AN? So AN equals A1 plus N minus 1 times D. So AN is equal to 131. And we don't know what N is. We don't know how many terms we have to get there. We could just keep adding 6, and on what term we're on when we hit 131, that will give us the right answer as well. But we'll use the formula here. A1 is 5 plus N minus 1 times, and we have to solve for N, times 6. So this is 6N minus 6. 5 plus 6N minus 6 equals 131. And you combine this, you get -1, so you'd have to add 1 and divide by 6. And if you solve for N, you get N equals 22. And you can double check that and make sure, but that's what I got. All right, write an expanded form. So really what they're asking is, what does this sigma N equals 1 to 4 mean of this geometric sort of sequence? This is going to be your A1. This is going to be your R. R and A1. So write an expanded form. It means it's a sigma, so it means sum. It means add it all up. So the first term is N equals 1. So you have 2 times 3 to the 0 power. 3 to the 0 power is 1, so it's 2 times 1, which is 2. And then you have 2 times 3 to the 2 minus 1, which is 1. So 2 times 3 is equal to 6. And then 2 times 3 to the second. And 2 times 3 to the third. And 3 to the second is 9, times 2 is 18, and 3 to the third is 27, times 2 is 54. So in expanded form, this just means 2 plus 6 plus 18 plus 54. It doesn't say evaluate. If it said evaluate, it would, you just add this all up. You'd be at 60, 78, 80. But just writing it out, this is what this sigma N equals 1 to 4 means. It means add these 4 numbers together. All right, number 6. Now this time it says evaluate. Figure it out. add up from 1 to 10. So A1 is equal to 2 times 1 plus 6. 2 times 1 is 2 plus 6 is 8. A10. Now you could do it for A2 and just keep adding. You're going to be adding 6 every, or adding 2 every time. For A2 it would be 2 times 2 is 4 plus 6 is 10. So it's going to be 8, 10, 12, 14. But we'll just do it with the formula. A10 is 2 times 10, which is 20, plus 6, so we're at 26. And then the sum formula, so we're summing up the first 10. All right, had a little interruption there, but here's our formula. The sum of the first 10 is n, which is 10, times a1, which is 8, plus an, which is a10 in this case, which is 26, divided by 2. Basically, we're taking the average of the terms we're adding up and multiplying by how many terms. And that is 170 if you add that up. Be careful on your calculator. Make sure you do the numerator first. So you got 34 divided by 2, 17 times 10, 170. A lot of people on their calculator, they do 8 plus 26 divided by 2, and 8 plus 26 divided by 2 is 8 plus 13. And so you get 21 times 10, 210. And that probably will be an answer if it's a multiple choice question. All right, Bob is a photographer. I think I changed the name on that question. So we start with 30 pictures. After each week, he sends in 4 more. So the next week, he sends in 34. Find the total number of pictures that he sends in after 12 weeks. So what we have is arithmetic sequence where we're adding 4 every time. So we want to find A12. A1 is 30. A12 is equal to A1, which is 30 plus n minus 1. So 12 minus 1, which is 11, times D, which is 4. So that's 44 plus 30, so it's 74. And now we want to sum up the first 12. How many total pictures did he send? So after 12 weeks, he sent 30 the first week, 34, then 38, then 42, and you add that all up, and I'll use the formula here. We got 12 times A1, which is 30, plus 74, which he sent in the last week, divided by 2. And that equals 624 if you do that on the calculator. And if it comes out to be something different, please let me know. Question number 8. This is a way to write an infinite geometric series where we're going 3/4 as high on each bounce, and we're finding the total feet that the ball drops. So the first drop is 16 feet, and then the next drop is 3/4 of that. So it drops 12 feet the next drop, and then it drops 3/4 of that. So it drops 9 feet the next drop, and we're going down by 1/4 every time. Let's see here. My answer looked a little wrong, but it's, so we got 16, 12, 9. So basically we take this 16 and multiply it by 3/4. So R is equal to 3/4. A1 is equal to 16, and in theory this thing just keeps bouncing, but when you keep multiplying it by 3/4, once you get down to an inch, then you have 3/4 of an inch, and pretty soon it's infinitesimal how much you're adding. And so it adds up when you add it all up, and if it keeps bouncing forever, you'd have A1 divided by 1 minus R. So 16 over 1 minus 3/4. 1 minus 3/4 is 1/4. 16 divided by 1/4, the same thing as multiplying by 4. So it totals the total sum, so this is a sum of an infinite, is equal to 64 feet. Now, when I dropped this a year ago, now it's at 63.999999999999999 feet. But, you know, sooner or later it's going to get 64 once we get out there to infinity. All right. Write in exponential form. So this is a formula: a b to the c equals log base x of c equals b. So you make sure you find that formula sheet. You'll have that for the test. But in exponential form, it's x to the second equals 4. So in this case, if it was solve, x would equal 2. Take a square root of both sides. And you can't have a negative base, so it would be a positive 2. And number 10, you invest $2,000 into an account earning 7% interest, compounded quarterly. So you'll have the compounded interest. So you have simple interest, compounded interest, and compounded continuously. The compounded interest formula, you have an amount that you're going to end up with. How much will you have after 11 years? The amount you'll have after 11 years is your starting amount, which is $2,000. On the formula sheet, we call that P, principal. And then it's 1 plus the interest rate, which is 0.07, divided by n, which is how often it's compounded. So it's compounded quarterly, so that's 4. And then you have to multiply 4 by however many years, so 4 times 11. And on your calculator, just raise it to the 44th power. Don't do 4 times 11. If you do 4 times 11, make sure you put it in parentheses. And that comes out to be $4,290. $4,290. And I'm going to pause, or actually I'm going to stop the video right here. So we did the first 10 questions, and I think I'll do that 10 questions a time for this practice final.